The process that we have talked about will be put into practice by using this sample project here. You see, it's a 14-kilometer base tunnel. This is the geological profile. Here's the chainage starting from 0 to 14 kilometers. And here's the time. So this tunnel will be built between 2020 and 2023. It consists of an access shaft in this area and then 2 NATM drives, which will excavate the starting cavern for the TBMs. We have 2 TBM drives going north, 2 TBM drives going south, and we have another drive from the north, which will start after an access road is built, that goes into this direction here and will excavate through this very difficult fault zone that you see here indicated by red, and then meet the TBM drives. So after that, all the tunnels are excavated and we can start building the cross passages that connect the twin tubes indicated by these small blue dots. And after that, we will build an inner lining. Also, in this area, we will build an underground refuge for safety reasons. Now, let's go into the software and see how we can model this project. This is the RIAAT start screen that you see when you double-click the RIAAT icon. Let's start with Workbook New and go straight to the gear wheel that you see here in this area and click it once. You have different tabs here. We are most interested at this point in the tab Cost Components. You see there are 2 icons. The first one is Create New Cost Component, and the second one is Create New Cost Components Group. To reproduce our hierarchical cost component structure that we've seen on the slide before, we need 4 cost components and 3 cost component groups. The first cost component is called Base Cost B, and we will assign a color which is blue in this case. Then we have 2 risk cost components, the first one being Identified Risk, abbreviation IR, and we will assign an orange color to that. The second one is Unknown, abbreviation U, and we will stick with the yellow here. And the last one, you might have guessed it already, is Escalation E, and we will choose a purple color for that. Now we want to take Identified Risk and Unknown and group it into Risk. So this rectangular icons here are cost component groups. So we call this one Risk, abbreviation R, and choose a red color, and then drag and drop it into the Risk group. We do the same for Unknown. And now we see that the aggregation of Identified Risk and Unknown will be Risk. We need 2 more groups, the second one being Base Cost plus Risk, abbreviation BR, and a dark red color, and we drop Risk into that group, and we take Base Cost and we drop it also in this group. So now we see the sum of Base Cost and Risk will be Base Cost plus Risk. The last one is now Total Project Cost, BRE, and we drop Escalation in there, and we drop BR in there, and we will assign a color to Total Project Cost, green, and we have our hierarchical cost component structure ready. Base Cost and Risk equals Base Cost plus Risk plus Escalation equals Total Project Cost. That's it for the cost components. We can press close here. And now let's look into the WBS. We start by clicking New Workbook. We call this one sample, let's say sample project. And then we can click on this icon here create new project. We call this one tunnel project, for example. And we can add new groups, such as construction contract, which consists of, for example, tunneling works and systems and civil works, polar structures, and then the group of tunnel works consists of an ATM tunnel and TBM tunnel and so on. And by creating more and more of these groups, we can build up our WBS. We have sliced up the RIAAT model into 5 submodels, similar to a cooking show where some of the steps are already pre-prepared to keep it more condensed and keep you interested. So what we do now is we go to Open, Workbook Open, and we select Model 1, Sample Project _ CCS. All of the steps that we've done already are included there, and some more, so which makes it easier for us to continue. We go to Property and right-click, and we go to this one here, New Cost Element. Click and select a cost component. So we select B, this is our base cost, and press OK. We can assign a name, let's say property, and a name for the subcomponent. Let's say this is property number 1, and this is the cost for property number 1. We want to buy 5,000 square meters of land. And we assume that each square meter costs about $1,000 US. You see these icons here are red because the simulation is not updated yet. So now we want to simulate a result, which is in this case $5 million US, deterministic. We can press this caret here and we see there is no probabilistic or no additional probabilistic information added. There's just a straight line here at $5 million US. Now we would like to add ranges. We press this icon here and select a triangular distribution and say maybe it's not $1,000 US per square meter, maybe it's 850 or maybe even 1,200 because that's the typical market range in this area. And we also want to change the quantities a little bit. We say maybe it's not strictly 5,000. It could also be 4,700, or it could also be 5,500. We're not 100% sure. So there's now a range to the quantities, and then there's a range to the price. We simulate again, update element, and now we see a distribution function. Actually, we see 2 different graphs. I'll go through the 2 of them real quick. On the left, you see that's the distribution density. The integral of the distribution density, so the sum of each of the orange bars, is the distribution function, which is the red line you see here. And this same red line is also shown on the right side, but with the difference that you can read out numbers directly here. So if we want to read out a P50 value, we see that's this one here. It's $5.1 million US. And if we want to see the range at a glance real quick, we see our range between P5 and P95 is 4.5 million and 5.8 million for this base cost element. We can either create cost elements by ourselves or we can import them from Microsoft Excel. Let's assume for the NATM tunnel, a design engineer has provided us a base cost estimate in Microsoft Excel, which could look like this. It consists of excavation and support, muck disposal, final lining, subcomponents, and cost line items. For example, this one here, excavation and support categories, profile 1 excavation, has a quantity of 840 meters. unit price of $1,263.04 US, and the multiplication of the two gives us a total price. That's the typical structure of a cost estimate. If you look into your RIAAT folder, you will have various templates for import and export into and from RIAAT. And our job now is to convert that information into a RIAAT template. I have prepared that already. And we have to carefully create the first 3 lines, and then we can just copy and paste it down. So I've connected all the information we have here to the template. For example, the name of the cost element is linked to this cell here, the name of the subcomponent is linked to that cell, and so on. The quantities are linked to the quantities, the unit prices are linked to the unit prices, and we have added ranges to it, indicated by these percentages up there, so that we get actually a range for our unit prices and for our quantities. If you have prepared that template, which I have now done already, then you just select the whole thing and press Ctrl+C, go back to RIAAT, and click on this icon here, Import Excel Data, and press Import, and you have your cost elements with all the information of the subcomponents, excavation, labor cost, support, ready. Now you see the updated cost elements and groups have now all turned red. The NADM tunnel is red, tunneling works is red, construction contract is red, owner's indirect cost, which includes the property cost that we've created before, is green because nothing has changed in this group, and the overall tunnel project is also red because the construction contract has changed. So we can update element, everything turns green, and now we know, okay, this is our base cost for the NADM tunnel. We changed the factor to 1 million, so it's easier to read, and we see the NADM tunnel costs between $80.1 and $86.7 million.